One of the most frustrating issues that students encounter when preparing for STEP is that even though STEP is designed with the A-level maths and further maths specifications in mind, it doesn't overlap perfectly with any single exam board. The issue is further compounded by the fact that on most A-level exam boards for further maths, you have a choice of optional module. In this series of videos, we're covering each exam board individually, outlining the missing knowledge that you will need to fill in if you want to attempt all 12 questions on the exam. In this video, we're going to think about Edexcel, using the most updated 2026 version of the specification for STEP. No matter which optional modules you're taking for Edexcel A-Level Further Maths, you will have some gaps in your knowledge, for both Step 2 and Step 3. In general, it's highly advisable to take the time to fill in these gaps in your knowledge. Not only because it will enable you to attempt more of the questions, you'll have a greater selection out of the 12 that you can choose from for your 6 to attempt, but also because, as a general rule, questions in STEP which use more advanced theory will often be easier in terms of the problem solving required. So you may enable yourself to capitalise on easier problems. In terms of how you can fill the missing knowledge gaps, one good option is simply to make use of an A-Level Further Maths textbook, in particular, looking at the modules which you didn't take from the optional selection. Remember, you don't need to cover the entirety of, for example, further mechanics if you haven't taken it as an option, only the bits relevant for STEP which we will highlight in this video. You might also like to make use of the notes provided by the STEP support programme, which are very detailed for some topics, though slightly sparser for others. We do also run a STEP preparation programme at Vantage Admissions, which introduces all potentially missing knowledge from scratch. While it is important to go through the STEP specification, make sure you're aware of what you don't know, and ideally learn that material, it's important not to obsess over this too much. It's not really in the spirit of STEP to find a very niche wrinkle of the specification and set a problem probing your factual knowledge on it. This is an exam which is far more focused on problem solving. So do learn the bits of the specification which you haven't covered already, but don't let it become a point of obsession over working through past papers. It's also really important to remember that STEP does not have a formula booklet. So not only do you need to be aware, for example, that certain formulae exist, you actually need to be able to recall them. And there is a detailed list of required formulae for memorization provided as part of the STEP specification. The compulsory content for Edexcel Further Maths is all pure, spread across Core Pure 1 and Core Pure 2. Students then take 2 out of 8 additional further optional modules. Further Pure 1 and 2, Further Mechanics 1 and 2, Further Statistics 1 and 2, and Decisions 1 and 2. You either need to take 2 Paper 1s or a matching pair of Paper 1 and Paper 2. So, for example, you could take Further Pure 1 and Further Pure 2. You could take Further Pure 1 and Further Mechanics 1, but you couldn't take, for example, Further Pure 1 and Further Mechanics 2. Because the combinations are a bit more complicated for Edexcel, it's less likely than on other exam boards that your school will give you a choice of which modules to take. If you do have a choice, note that Decision is pretty much completely useless for STEP. Further Pure 1 covers quite a lot of material which is relevant for STEP, and both the mechanics modules also cover a great deal of STEP relevant material. There's only a very small amount of STEP relevant material on Further Pure 2, and although the further statistics options do cover material relevant for STEP, they also cover quite a lot that isn't and might be better avoided if you have the choice. Regardless of whether you take any optional Further Pure modules, all students following Edexcel will have some missing knowledge from Pure Maths that they need to address for STEP. For both Step 2 and 3, you'll need to learn the notion of if and only if, or equivalently, necessary and sufficient conditions. Now, although this is not covered in the A-level, it is required knowledge for the TMUA, and if you haven't covered these ideas before, a good place to start is actually the Cambridge Notes on Logic and Proof, which are provided for the TMUA. You'll also need to learn the remainder theorem, which is a very simple generalisation of the factor theorem. In fact, a really good exercise is to convince yourself that starting from the factor theorem, you can prove the remainder theorem. You'll need to be prepared to perform polynomial division, where the divisor is of greater degree than linear. For example, division of a polynomial by a quadratic factor. You'll need to handle more complicated rational functions, including their graphs, and even thinking about oblique asymptotes. You'll need to remind yourself of circle theorems, which are almost always covered in GCSE, but not always explicitly on the A-level. So although at one point you will have been an expert on these circle theorems, students often find by the time you're thinking about STEP, you start to feel a little bit rusty. You'll need to know the expression for the binomial coefficients in terms of factorials. This is often covered at least informally in school, but make sure you have a recall of the formula. Remember, there is no formula booklet for STEP. You'll need to have an informal understanding of what it means to talk about a limit of a sequence, what it means for a sequence to tend to a limit. You'll need to know the change of base formula for logarithms, and it's a good and straightforward exercise to derive this algebraically from scratch. You'll need to be familiar with the idea of polynomials with complex coefficients. Really, there's not a lot to learn here, other than the fact that the roots no longer need to come in complex conjugate pairs. You'll need to know the relation between the roots and coefficients of polynomials beyond the case of a quartic. This really is just a matter of continuing on the very obvious pattern which holds up to quartic. And you'll need to be prepared to deal with partial fractions where the degree of the numerator is equal to or greater than the degree of the denominator. For step 3, you might also need to cover a little bit more detail on hyperbolic functions, including notations like sech and coth, and a bit more information about identities that exist among hyperbolic functions. If you don't take FP1, there are some further knowledge gaps for pure that you will need to address. For step 2 and 3, you'll need to be prepared to deal with more complicated inequalities involving algebraic fractions. You'll also need a little bit more explicit detail and understanding of limits of functions, although note that FP1 actually goes even further than you need. For example, on STEP, they will not assume that you know L'Hopital's rule. You'll also need to be prepared to recognise and use the Cartesian equations of hyperbolae and ellipses, and for hyperbolae, you'll need an understanding of their asymptotes. Again, do note that FP1 actually goes a little bit further here than you'll need, with lots of explicit detail on the parametric forms of these curves. The parametric representations can certainly be useful on STEP, but they're not assumed background knowledge. On step 3, you'll also need to learn about the vector product and its applications, including, for example, to the computation of areas, and the method of substitution for differential equations. FP2 overlaps less strongly with the STEP specification, and if you don't take FP2, there's only a small amount of extra material that you'll need to cover. For step 2 and 3, you'll need to know about permutations and combinations, which is covered to a good level of detail in FP2. You'll also need to know about reduction formulae for integration, although this is quite a self-explanatory topic. For step 3, you'll also need to learn the formula in terms of an integral for the length along the arc of a curve. For mechanics, there's some extra material that you will need to learn, even if you do take the optional further mechanics modules. On step 2 and 3, you'll need to know about the idea of a triangle of forces. This is simply the statement that if you have 3 forces acting on an object in equilibrium, if you join up the vector arrows of the 3 forces, nose to tail, they must form a closed triangle. And this geometrical intuition can sometimes be useful. You'll also need to be prepared to resolve forces in 3 dimensions, although this is fairly self-explanatory. For step 3, you also need to know that simple harmonic motion can be used as an approximation to the oscillations of a pendulum. The basics of simple harmonic motion are actually covered in Edexcel in the compulsory core pure content. If you don't take FM1, there is some extra mechanics material that you'll need to cover. For both step 2 and 3, you'll need to be more familiar with the idea of work, energy, and power, especially the use of conservation of energy as a problem-solving technique in mechanics. If you take A-level physics, you may already have some familiarity with these ideas. You'll also need to be familiar with one-dimensional collisions, in particular the use of conservation of momentum, and the idea of a coefficient of restitution. You'll also need to learn the basics of elasticity, Hooke's law for tension, and the formula for elastic potential energy. For step 3, you'll also need to learn about oblique collisions and the idea of impulse. If you don't take FM2, there are also some extra knowledge gaps that you'll need to address. For step 2 and 3, you'll need to handle more complicated rigid bodies and moments problems, with forces at awkward angles that may not be, for example, perpendicular to the object. You'll also need to handle the idea of a centre of mass in simple cases where the centre of mass is deducible by symmetry. For step 3, you'll need to cover more complicated ideas around centres of mass, including the use of integration to determine centres of mass, and in cases where the object is formed as a volume of revolution. You'll also need to learn about circular motion, which is a really substantial topic to address from scratch, slightly more complicated applications of differential equations, including the formula A equals V dV dx. This is really nothing other than an application of the chain rule. Finally, students who haven't done FM2 might like to look at a little bit more simple harmonic motion material, specifically in a physics context, although technically you do meet the remit of the specification from Core Pure. Regardless of whether you take optional statistics modules, there will also be some material from stats that you need to address for STEP. For step 2 and 3, you'll be required to use permutations and combinations to solve probability problems, specifically in the context of equally likely outcomes. There's also the conversion of a normal distribution to a standard normal distribution via the use of translation and scaling. Although this isn't officially part of the A-level specification, in practice many teachers will actually cover this regardless. You also need to be prepared to use the normal distribution as an approximation to the Poisson distribution. For step 3, you'll also need to be familiar with key results from the algebra of expectations. If you don't take FS1, there's a little bit of extra statistics material that you'll need to cover, and this is all relevant for both step 2 and step 3. You'll need a little bit more intuition behind what a random variable is, and you'll need to be proficient dealing with discrete random variables, including the calculation of their expectation and variance. You'll need particular expertise working with Poisson distributions, not only calculating their probabilities, but also their expectation, their variance, and also the use of the Poisson distribution as an approximation to the binomial distribution in appropriate cases. If you don't take FS2, you'll need to learn about continuous random variables, which are a really important topic for both step 2 and step 3. For step 2 and 3, you'll need to know what a continuous random variable is, and you'll need to be proficient with probability, density functions, and cumulative density functions. You'll need to use these to work out probabilities, as well as basic properties like means and variances. For step 3, you'll also need to work out the expectation not only of a random variable, but also of a function of a random variable. And you'll need to be prepared to use a cumulative density function to determine the probability density function of related random variables. Note that here we focused on the most updated version of the STEP specification. If you look at older papers, especially those prior to 2019, you may see some other topics like moments of inertia and probability generating functions, which are no longer examinable. These can be safely ignored. We've also focused on the official specification. Like with any admissions test, there are going to be tricks, ideas, and methods which recur on STEP, but which are not an official part of the specification. And you'll gain familiarity with these ideas by working through past papers. If you'd like intensive support with your STEP preparation, we also run a STEP preparation program at Vantage Admissions, which not only addresses possible gaps in knowledge, but also places a great deal of emphasis on this extra secret syllabus. If you'd like more STEP videos, do remember to subscribe, and thank you very much for watching.